Okay, let's now go to this question of what's the probability that my bias causes high readings based on just this one 32 timing sample. Let's say that's all we had. So what would be the chances that my inherent bias would actually be greater than, would actually be such as to make my timings a little longer than the actual? Okay, well, let's pretend that this 1.865 second interval, which is the ideal, is the actual. So let's suppose that this really is a pendulum that's very close to the ideal, and it probably actually is. So let's assume the actual is 1.865 seconds. That's going to be represented by the middle of this normal curve, because anybody is going to tend to have a bias that makes them go a little higher or a little lower, and that bias is going to be governed by some standard deviation. Okay, so in my case, the standard deviation, at least as far as we can determine it from this data, the standard deviation of my individual timings is 0.049 seconds, which means that the standard deviation of 32 trial timings, 32 interval trials, would be 0.009 seconds. So, assuming then an actual of 1.865 seconds and a standard deviation of 0.009 seconds, well, I was 0.01 second high, wasn't I? Because this is 1.01 second greater than this, so that this 0.009 seconds is not quite 0.01 seconds. My 0.01 seconds would be out about here. So this is my 32 trial mean based on one trial, and I'm using the word trial a little, not just a little, a whole lot ambiguously. I want to call that a 32 interval timing. I've got way too much of this stuff. I'm unlikely to be able to correct this very neatly, but let's try anyway. Okay, so I'm going to call this not a 32 trial mean, but a 32 interval trial. Okay, that word interval might be a little hard to read, but and that's one trial. Okay, so my 32 interval mean on one 32 interval trial was a little more than one standard deviation above what we might expect my 32 interval losing my sentence there. My 32 interval mean appears to be about to have a standard deviation of 0.009 seconds, and the 0.01 second deviation, not from the mean but from the actual period, appears to be a little more than one standard deviation. Now, what's the probability that my mean is actually 1.865 seconds? Well, if I'm this far above the mean, that leaves only about a little more than 10% of the distribution to the right. I'm so far above that it appears that about 90% of the distribution is to my left, and that's going to give me a measure. I'm not going to go into detail because that can be a little bit subtle, and if I say much more it's going to be a little bit misleading. But that tells me that there's at least a fairly good chance that my 32 interval mean is greater than the actual. So if you were to have an opinion on my 32 interval mean, it would be that it is higher than the actual, but not so much so that it's really a compelling result. Okay, it could be that just by chance I just happen to be a little more than a standard deviation above the mean on that one 32 interval trial, and you would need a lot more 32 interval trials to determine whether that's actually the case. But it does seem more likely than not that I tend to time a little bit high.